All right, I want to do a quick video on part 3 of our series, solving logarithmic and exponential equations. Okay, so with these types of problems, once again, we've got log base 36 of x equals 3 over 2. And so what we're going to do is we're going to kind of do like we did before, a little G-shaped thing, right? And that allows us to see that x equals 36 to the 3 over 2. Now what you want to do with this is you say, okay, well 36, that's just 6 squared. So you're going to have x equals 6 squared 3 over 2, which then yields us x equals 6 to the third, which then gives us 216. We went from x squared times 3 over 2 to 6 to the third because those 2's cancel out when you multiply these together, right? All right, so what I want you to do is in the comments, you got this problem, log base 9, x equals 3 over 2. Which answer do you think it is? A, B, C, or D? All right, let me know in the comments what you come up with. Now, the next problem that we're going to do, like I said, I'm going to try to make this quick, is we've got log base 2 of x squared minus 4 equals log base 2 of 3x. So how we can deal with this problem is we say, okay, well, if they're both base 2, just like we had with the exponents, that must mean the insides are the same. So I'm just going to go ahead and set the insides equal to each other. Now, when we're dealing with a quadratic equation, it's very important that we get everything to one side. How do I know this is a quadratic? It's because we have this x squared term here. So I'm going to bring this 3x over by subtracting it on both sides. There are no like terms over here, so I just write x squared minus 3x minus 4 equals 0. Now I've got to find two numbers that multiply to give you -4, but add to give you -3. Those two numbers are going to be -4 and +1. So I end up with x plus 1, x minus 4. If you don't know how to factor, make sure you take a look at the videos that we have on factoring. Then now that we've got x plus 1, we got x minus 4, what we can do is we can now say, set both of these equal to 0. And when we do that, we find that x equals -1 and x equals +4. Now the question here is, are both of these answers valid? Okay, so let's look at the first one. In the first one, using x equals -1, we would have log base 2 of -1 squared minus 4 equals log base 2 of 3 times -1. And once again, I'm just filling in the blanks on these x's here, down here, which gives us log base 2 of 1 minus 4 equals log base 2 of -3. Now we've got a problem, because can you have log of a negative number? No. Why is that the case? It's because, well, let's think about it. If I have, like, we're looking at base 2. If I have 2 squared, that gives me 4. That's going to be a positive. Even if I have 2 to the -1, a negative number, that gives me 1/2. So I'll never actually, and if you graph it, you'll see that my y values will never be negative, right? I can get as close as 0. I can get real close. I can even get to, I can get real close to 0. I can't actually hit 0 itself, right? So I'm going to get real close to 0. But you can see that, it's not going to actually hit it. So that said, we know that these negatives cannot be an answer. So the only answer lies in x equals 4. And we can, of course, prove that by just doing something real quick. log base 2, 4 squared minus 4, log base 2 of 3 times 4, which gives me log base 2 of 4 squared is 16 minus 4 is 12. Log base 2 of 12. 3 times 4 is 12. Okay. All right. See if you can figure out which one of these answers is correct. You've got log base 3 of x squared minus 15 equals log base 3 of 2x. Is it -3, -1, 5, or 15? Let me know in the comments what you get. All right, another type of problem is we can deal with inequalities, not just equations. And in this inequality, we've got log base 3 of x equals 4. It's real simple. Kind of think about it the same way here. We're going to use our little trusty little g thing here. We've got 3 to the 4th. And it's going to be very important that we, and as a matter of fact, let me do it this way. Let me look at it like, let's put the x down here, just so that we can make sure that our signs are in the right place, in the right place. And then that means we got 3 to the 4th on the other side, which 3 to the 4th is 81, and that's how you do it. So real simple, kind of doing the same thing that we were doing before. Your question is, if we have log base 4 of x is greater than or equal to 3, is it I, j, k, or l? Let me know in the comments below. All right, last problem, kind of similar to what we were doing before. All right, we've got log base 5 of 2x plus 1 is less than or equal to log base 5 of x plus 4. And the way that we're going to do this problem is, so we got log base 5, we can just set these equal to each other. So that gives us 2x plus 1 less than or equal to x plus 4. And that's our first step. Then what we're going to do is we're going to get all the x's to one side, all the numbers to the other side. So I'm going to subtract x from both sides, and I'm going to subtract 1 from both sides. That brings this 1 over here, brings this x over here. That gives me x less than or equal to, let's see, less than or equal to 3. All right. Now, we're not quite done. And the reason we're not quite done is when we deal with inequalities, okay, we deal with inequalities and we're saying that x has to be less than or equal to 3 in particular, we got to start thinking, okay, well, that's true, but we know x can't be negative, all right? But more importantly, what's inside of these logarithms can't, well, it's not that x can't be negative, it's that what's inside of these logarithms can't be negative. So let's find out what those are. So we got 2x plus 1 equals 0, which yields us 2x equals -1. Now I can divide both sides by 2, and x equals -1/2. Or we could also say, if we look at x plus 4 equals 0, we can say x equals -4. So in other words, we know that x needs to be greater than both -1/2 and -4, right? It can't be lower than -1/2. Obviously, -4 is less than -1/2. So you can't be less than this. Why? Because as soon as you do, you start getting less. This thing right here, this piece right here becomes negative. So what we really say is -1/2. It can't be equal to it, right? Can't be equal to -1/2 because actually it probably should have said greater than or equal to, greater than or equal to, just strictly greater than, my bad. Yeah, strictly greater than. So -1/2 is the lowest I can go. Then x greater than or equal to 3, and this is my answer. It's this set. All right, given this problem, log base 4 of x plus 3 is greater than log base 4 of 2x plus 1. See if you can tell me in the comments which answer you think is correct. I hope this video was helpful, and I'll see you guys next time.